In this video, we will recall some of the important properties of the absolute value and apply these to solving some inequalities involving absolute values. So first of all, let me remind you that the absolute value function is defined in a piecewise way. Recall what the absolute value does. The absolute value is going to take a positive number and give you out that positive number. Or if you plug in a negative number, what it's going to do is take the opposite of it so that you get out a positive. And really you can think from a geometric perspective, the absolute value of x is measuring the distance that the number x is from the origin. So graphically, just to remind you, if we would like to sketch the absolute value of x, for x bigger than or equal to 0, we're thinking y equals x. And to the left of 0, we're thinking y equals minus x. So for x bigger than or equal to 0, we have y equals x. And to the left of 0, we have y equals minus x. And you get this hopefully familiar looking V shape, which is the graph of the absolute value function. Now, some of the basic properties. The absolute value of a product is the absolute values of each of those terms multiplied together. If you take the absolute value of a fraction, that becomes the absolute value of the top over the absolute value of the bottom. And in terms of solving inequalities, we have the following two very important equations. To say that the absolute value of x is less than a, well, that means if x is positive, it is smaller than a. But if x is negative, it has to be bigger than minus a. Likewise, if you want absolute value of x to be bigger than a quantity a, well, x is positive and bigger than a, or x is negative and less than minus a. Let's look at a few examples of this in action. So the first inequality we have is that the absolute value of 4y plus 5 is less than or equal to 11. And the first step involved with solving one of these absolute value inequalities is to rewrite the inequality without the absolute value. So this expression 4y plus 5, if it is positive, it has to be less than or equal to 11. And if it's negative, it has to be bigger than or equal to minus 11. And that's a very important step because once we write it in this form, it becomes an old problem for us to solve. Manipulate it step by step until that solution appears. So now what we can do is subtract 5 from both sides. So we will have minus 16 is less than or equal to 4y is less than or equal to 6. And then we can divide both sides by 4. So minus 4 is less than or equal to y is less than or equal to 6 over 4. And 6 over 4 simplifies nicely down to 3/2. So in terms of interval notation, we would have the closed interval going from minus 4 up to 3/2. A graphical representation, minus 4 to 3/2, both of those points are included, so we have closed circles. So another very similar type of problem, where is the absolute value of 2x minus 7 greater than 5? Well, let's express this without the absolute values. If 2x minus 7 is positive, we would have 2x minus 7 being larger than 5. But there's also the possibility that that expression 2x minus 7 is negative, and in that case we would need 2x minus 7 to be smaller than minus 5. And now we manipulate each one of these individually, and because of the or, we'll end up combining our solution with a union symbol. So 2x minus 7 less than minus 5. Add 7 to both sides. 2x less than 2. Divide by 2. X is less than 1. For the second inequality, proceed similarly. Add 7 to both sides. 2x is larger than 12. Divide by 2. X is larger than 6. So express our solution in terms of an interval, x less than 1 is minus infinity to the open interval at 1, or becomes a union in x greater than 6. So the open interval from 6 to infinity. In terms of sketching a solution on the number line, we have 1 and 6. 1 is not included, but everything to the left of it is. 6 is not included, but everything to the right of it is included. So the important observation is that whenever you're going to solve an inequality involving absolute values, the first step towards solving is to rewrite it without the absolute values, and that expresses it in terms of an old, hopefully more familiar problem.